seeing 24, you got a squared plus b squared equals c squared. And we got 6 squared plus 6 squared equals x squared. This also happens to be a 45, 45, 90 triangle. So you might remember the rules for
Mhm.
that. If you don't, you can still use the Pythagorean theorem here. So x equals the square root of 72. And you end up breaking this apart, 2 and 36. Whenever you see a perfect square like that, you just break it apart. So it becomes 6 square root 2 for that.
Okay.
It would be better to use the 45, 45, 90 triangle stuff, but if you're not familiar with it or forgotten, you can always go back to this. So y and y are the same here.
Mhm.
This one I actually kind of do need to use the 45, 45, 90 triangle. So here's the short leg. I'm sorry. Here's the leg, and here's the hypotenuse. The leg times the square root of 2 always equals the hypotenuse. In this case, the hypotenuse is 15 square root 2. The leg times the square root of 2 is here. So you can see that these two numbers have to match. The answer is 15 for that. In the previous problem, you will see that the legs were 6 and 6. So the hypotenuse is the leg times the square root of 2. That's why it's 6 square root of 2. Or you can do all this stuff on the right. Either is correct, but you have to get to where you you're comfortable with that. Okay. 26. Okay, the length of the sides of a square is 10 centimeters. So we'll draw our square, 10, 10, and 10 all the way around. Find the lengths of the diagonal of the square. Okay, so if we're doing that, now we're converting the square into a right triangle.
Mhm.
And we want the hypotenuse. We already said the hypotenuse is the leg times the square root of 2.
Okay.
So you gotta have that down. And we'll move on to number 27. Okay, so 27 and 28, at least that's as far as I've scrolled down. These are 30, 60, 90 triangles,
Okay.
and we'll review the reference triangle that goes along with them. So the short leg is over here. The short leg is there, the long leg is here, and the hypotenuse is here. So the hypotenuse is equal to the short leg times 2. So if you know the short leg, which you do in this problem, you can double it to get the hypotenuse.
Mhm.
So that means it would be 10. It would be 5 times 2. Now, how do I know it's the short leg? Well, it's across from the 30. Across from the 30 means that it's the short leg.
Okay.
Let's look at 28. All right, so across from the 30 is no side. Across from the 60 is the long leg. Okay, so they're giving you the long leg this time. And they're giving you the hypotenuse.
Mhm.
Okay, so just like from the previous problem, the short leg times 2 is equal to the hypotenuse. And we know the hypotenuse in this problem is 50. So what is the short leg? Divide both sides by 2. The short leg is
25.
25. So if you can get the short leg, you're in good shape, because the short leg leads you to the hypotenuse, which is what we just used. It also leads you to the long leg. So
Mhm.
the short leg times the square root of 3 is the long leg.
Okay.
So since your short leg is 25, 25 times the square root of 3 is the long leg. And that's all it is. It's right there. So in
Okay.
general, like kind of the 80-20 rule, is the long leg always has a square root of 3 in it? Not always, but it could for these. So that could be another little hint there to figure out the right answer for this.
Okay.
Okay, moving away from nice triangles, we're moving into right triangles where you have to find either the legs or the angles. And this is your SOHCAHTOA stuff here.
Okay.
So you're trying to find x. Okay, I have this angle 67. What is x relative to this angle? And I have some options: opposite, hypotenuse, adjacent, hypotenuse. Well, x is opposite, and 20 is hypotenuse. So the sine of 67 equals the opposite x over 20. So to solve for x, you're going to multiply both sides by 20. So x equals 20 sine 67. Now you're using your calculator. Make sure your mode is in degrees.
Okay.
For almost this entire test, your mode should be in degrees. I don't think there's any exceptions to that, but you know, maybe if you grab one from a friend, I mean, you could do all sorts of things that are just horrible. So if you got a calculator, grab it and let me know what you get for a final answer on that one.
Okay, 1 second.
Sure.
Okay, I got 18.4.
Agreed. Excellent. Okay.
Okay.
All right, number 30, snipping that in. All right, find the measure of the angle of elevation of the sun when a pole 25 feet casts a shadow 42 feet long. So here's your pole. Here is your shadow. Makes a triangle. So this is 25, 42. It's a right triangle. We assume that. So the angle of elevation is here. I'll call this angle A.
Okay.
So relative to A, 42 is the adjacent, and that's the opposite. Which trig function are we using when you have the opposite and the adjacent? Tangent. So the tangent of this angle, call it A, is equal to 25 over 42. So there's a small amount of being unclear here. To get to A, you have to undo tangent. This ratio of numbers over here is not the angle. You have to undo tangent with the tan inverse. For most calculators, that's second tangent. And let me know what you get for an answer on that one. If you get letter A, that's the correct answer for this one.
Yeah.
Great. Moving along to 31, which is the angle of depression in the figure below? Which is the angle of depression? So the angle of depression is related to the angle of elevation. The depression is this angle right here, AOT. So that's the correct answer. I'll point out here, because I don't know if this will be, this is the angle of elevation there, and they are the same. These end up being the same because they're basically parallel lines cut by a transversal. So that's the depression, which is a weird word but it's true. Elevation there. Okay. I don't know. I don't think that'll be on there because that's you would just think that the it's using this information is would be another problem that you would see, but I don't know. I believe it's all multiple choice, probably 50 questions. I think that's what students have told me in the past. Okay.
Yeah, I think she said it'd be like 40 something questions.
40 questions. Okay. All multiple choice makes it easier for them to grade, things like that. All right. So now we're moving into, I would think, the more difficult stuff. This is not a right triangle. And everything we've done up until now has been for right triangles. Last 10 or so problems. So how do we do non-right triangles? There's two options. There's law of sines, and the other one is law of cosines. I don't know which one this is at the moment. If you have access to online calculators during this exam, which I don't know, I'll send one here in the chat. You can at least use it. Let me just grab this link. Yeah. Okay. So I'm going to put this in the chat. You can use this now to just check problems, or if you have the availability to use it during exam. It's very helpful for non-right triangles. It helps you to find the missing sides. So I'll show you how to do this problem. So we have to put in the given information. The measure of angle A is 72. The measure of angle B is 37. And we want, so A to C is 200. So that corresponds to side B. And they want the distance from A to B, that's side C. Okay, so you could go to that link I sent you, and if you enter in the information, it will give you the correct answer. Okay, but if you have to do this by hand, this is a law of sines problem, which also gives you the correct answer. So you're trying to find this angle C. So it's C over the sine of big C. That's this angle up here equals, and then we're gonna do go B over the sine of big B. Hopefully you saw that in class. So big C we get from subtracting from 180. 180 minus 72 minus 37. What is that? 109. So 71 degrees. Yes. So this becomes C over sine 71 equals B, which is 200 over sine 37.
Okay.
So you solve that proportion. Well, you're actually not solving it. You're just moving the sine 71 over to the other side. So C equals 200 sine 71 over sine 37. If you have a calculator handy, or if you've already ran it through that online one, you can let me know the result.
176.6.
Well, that's no good because that's none of the answers there. So maybe I didn't add right. 143. That seems right. 200 times sine 71 over. Okay, so I got 314.2 for this. Now, if you use the online calculator, you have to be very careful that you get the right things in the right place. It doesn't know whether you're doing it right or wrong. So that's a law of sines problem because it's giving you an angle side pair, and we can cover more of why that works or doesn't work. But let's go to 33 next.
Okay.
Snip this in. Okay, find find y in triangle xyz if the measure of angle y. Okay, so I always draw the same triangle x, y, z, and I always label it the same way. You can label it however you want, but it's got to be in that order. Measure of angle y is 36. Angle x is 49 degrees, and little x is 12. Little x is across from big X, and we want to find y. We want to find y down here. So this is a better version of law of sines because you already are given the angle side pair. So it's y over the sine of big Y equals x over the sine of big X. So your y is unknown, but your angle is known, sine of 36. X is your side, 12 over sine 49. So then you're just solving this calculator. So now let's say you're using the, let me write the solution here. So it's 12 sine 36 over sine 49. So let's say you're using that calculator I showed you. You'd have to say, well, this is really A, this is really B, this is really C. And then this is little b, this is little a.
All right.
And that's how you have to make a mapping of it to make it work for you.
Okay.
All right. Did you get a number for that? I haven't done it. I'll do it right now. So it looks like it's 9.35. Letter B.
I don't know if my calculator is in degree mode because when I went to the mode, it says it's in degree mode, but then like my answer was 8.8.
Well, let me try it here. Let me try it not in degree mode. We'll see.
Okay.
Yeah. You're typing like 12 sine 36 divided by sine 49.
Mm-hmm.
Like close parentheses, like that. 12 sine. This is what you should be entering. Slash sine 49.
Oh, okay. There we go.
Great. Okay, so good news here is after we get through some of these law of sines, law of cosines problems, the rest of it does kind of get less sophisticated with the calculations, but you're going to get some of these. So you gotta decide how you're going to attack these problems. So find the length of the third side of a triangular garden if two sides measure 8 feet and 12 feet, and the included angle measure is 50. So I'm going to just draw a triangle again. That's not the one I like. Okay, I'm just going to go A, B, C since it doesn't tell me. The two side measures are 8 and 12, and the included angle is 50 degrees. So we need to find this third side A. So this is a law of cosines problem. And how you know that is you're given a side, angle, side. So law of cosines is used when either given side, angle, side, or side, side, side.
Mm-hmm.
Okay, so now this has a bunch of forms. Okay, but the thing you have to remember is that these angles, these match. C and whatever's here, big C match. Because there's other forms that this can take on, but this is like the primary one that you see. We're trying to find side A. So A squared equals cosine A over here. See how these are matching? Those letters will always match. The A and B are the other two sides. So your other two sides are B squared plus C squared. And then it's always -2. And then this is AB because these A and B are here. This is BC because B and C are here. Now, if you have all three formulas, you just grab the one that solved for the one that you want. But this is how you do it if you don't have the formulas. So now we just plug the numbers in. 12 squared plus 8 squared minus 2 times 12 times 8 cosine 50. So on the right, you get a number, but that's not your final answer. You have to take a square root of that number.
I got 84.6.
Great, I got the same value. Notice that's not there because you have to take the square root of that number to get your final answer.
Okay.
So when you take the square root, you should get 9.2. I'd like to skip 35 and 36 unless you tell me strongly not to, because I want to make sure we get through as much as possible. You can always come back, but it's up to you. You're the customer. You tell me.
Can we do them now, please?
Yes. All right, so I'm snipping in 35. All right, so they give you a triangle this time. They say triangle DEF. I always draw the same triangle and I label it the same way, DEF. They're giving you three sides, 20, 25, and 30. And they want you to find angle F. This is the one we're trying to find. So I said this before, it's law of cosines when you're dealing with side, which is the case here. Now the problem with what we've done in the previous problems is I've given it to you in terms of A and B and C. So you have to realize this is really A, this is really B, this is really C. And so it gets challenging. You want to find C this time. Okay. Which is totally doable. But so C squared is really F. So that's 30 squared equals A is really side across from B 20. B is really 25. And then we're just putting those numbers in cosine big C, or cosine F in this case. So this is the worst type of worse than the previous ones because you got numbers on both sides. Probably it's worth writing out the numbers. So it's 400, 625 minus, what is that? 1,000? No, I'm losing my mind here. Yeah, minus 1,000 cosine F. So then you start moving things around. Like this is 1,025. So you move this over, you subtract that, you get minus 125 equals minus 1,000 cosine F. Divide by minus 1,000. So you have minus 125 divided by minus 1,000 equals cosine F. And just like we did in those early right triangle problems, you take the cosine inverse. So F equals the cosine inverse of minus 125 over minus 1,000. You should get 82.8 degrees. Let me know when I can move on to 36.
I'm good. We can.
Okay. All right. 36. Snipping it in. All right. All right. In triangle ABC, so again, I'm going to draw the triangle.
Mhm.
A, B, C. Little a is 12, little b is 8, and measure of angle A is 40. Find measure of angle B. So you use law of sines when you have an angle side pair. So this is an angle side pair right there. Okay. And that allows you to find other things. So in this problem, we're doing the sine of big B over little b equals the sine of big A over little a. And then we're just substituting the values that we know. So we don't know the sine of big B, but we know that little b is 8. Big A is 40, and little a is 12. So we haven't done a variation on this yet. Here you have to solve for sine B. So sine B equals 8 over 12. You're just moving the 8 up here in front of that, sine 40. So this on the right is a number. The number you're going to have to undo with arc sine or inverse sine. So what most students do, and I'd probably recommend this as well, is you get your number, whatever that number is, and then B equals the sine inverse of that number.
Mhm.
So let's see if we can get those numbers for you. So 8 over 12 times sine of 40. And this is 0.4285. And then you're going to take the inverse sine or arc sine of that number there. 25.4 degrees. And that is well, they don't really they round pretty early, but that's good enough. All
Okay.
right, take a deep breath, because that's I think that's the hardest stuff you're going to see on here. But it's but the thing is, it's all weighted the same. So like if you don't feel comfortable with that, you're going to miss some points. But you
Mhm.
want to make sure you can do everything, not just focusing on one stuff. Okay, so name a radius. A radius goes from the center to the edge of the circle. So like x to b is definitely 1. AB is this is actually a diameter. BC is a chord, and AC is maybe called a secant, I guess. Okay, so name a
Mhm.
chord. A chord, it starts and ends on the circle, but it does not go through center.
Okay.
So which one does not go through the center? So X to B, that's a radius. That's not
Mhm.
correct. A to B is a diameter. Oh, it's the same answers again. Okay. Well, there it is. There's your chord. Okay. A tangent, it touches the circle in one place. So that's B to D. So
Okay.
like they just hit kind of nicely like that. And I call it like a touch, like when a curve touches the x-axis. Okay, the 40, okay. The wheels in Elliot's truck have a circumference of 22 inches. That's the distance all the way around. Circumference is pi times diameter, or circumference is 2 pi r. You get to decide which one you like. They're exactly the same. You need to determine the radius. So I would suggest using this one. 22 equals 2 pi times the radius. So you're going to divide both sides by 2 pi. So it's 22 divided by 2 pi equals the radius. If you're putting this in your calculator, it's 22 slash parentheses 2 times pi. Calculator
Okay.
doesn't know to multiply before dividing. So that's 3.5 inches when you do that.
Right.
Okay, 41. In circle C, the measure of arc AB is 72. That should say 72 degrees. Find the measure of B to C to D. Okay, so they're saying A to B is 72 degrees. The central angle is 72 degrees also. So it's like whatever this is also the same. This is the central angle.
Mm-hmm.
Now, if it's cut by a diameter, this whole thing is 180 degrees. So in your problem, this right here, I'll call this x. X plus 72 equals 180. So x must be 108 degrees. So we mentioned this earlier, there's really two strategies. Usually you set things equal or they add up to, and often it's 180 is the answer to a lot of these. All right, 42. All right, find the length of PQ in circle R to the nearest hundredth. So there is a formula for this. S, R, and theta. S equals R theta, but theta in radians. So I don't know if you saw this. If you haven't, I can give you another formula that's a little bit more, I think, intuitive, but it looks a little more complicated. Do you remember that one? Is that familiar?
No, I don't think so.
Okay, so the circumference is 2 pi r, okay? But we don't want the circumference. We only want this little piece here. So this little piece is related to this angle. So I'm gonna call it S. So the CS is really the angle you have out of 360 times 2 pi r. So notice if your angle goes all the way around, that's 360 degrees. So what does this become? It cancels out to 1 and just becomes this 2 pi r, which is the circumference formula. You only want part of the circumference. That's why I like this formula. I think it's a little bit more intuitive. You only want 60 out of 360. That's your angle, 60 out of 360 times your circumference formula, 2 pi times 3.
Okay.
So go ahead and try that in your calculator and see what you come up with, please.
I just got 3.14.
Agreed. Excellent. All right. Nicely done. Okay. So moving along to 43. Find CF. Okay, so where's CF? So there's CF. CF is there. It tells you that AB is 12. Okay, I don't know why that's useful. OE is, oh, okay, I know why it's useful. So if A, B, and CD, they meet at a right angle, they're the same. So AB is really CD. And it's like if we were taking this class from the beginning, I would say you don't make these assumptions, and these are, you don't want to do this stuff, but like on this exam, you kind of need to like say, oh, it looks like they're the same. So And it looks like they're cut in half, so they actually are. So that's 6 and 6. OE is 4, which means that OF is 4. CF, okay, well, it's 6. So there is some measure of like probably just making some reasonable like assumptions that yeah, they kind of look the same.
Okay.
So they are the same. You're at a point in the class where that's not going to work against you too much. Okay, find the radius of a circle if a 48 centimeter chord is 7 centimeters from the center. So picture, here's your circle. Here is your chord. That's 48. Here's your center. That's 7. These are equal. Why are they equal? Well, we don't really have to explain why, but it's very much like this picture up here, where these are the shortest distance is always a right angle, meets at a right angle. So this is 24 and this is 24. And now you're trying to find the radius.
Mm-hmm.
So you're building a triangle here. Okay, and you can use the Pythagorean theorem. A squared plus b squared equals c squared. 7 squared plus 24 squared equals r squared. You end up finding that r equals 25 when you're done with that. All right, moving along to 25. Okay, 25. Find the measure of angle ABC. So this is ABC is right here. That's the one we're trying to find. Do you agree with that? You see that?
Mm-hmm.
This is what's called an inscribed angle.
Okay.
So whatever that is, this is 2x. So some students learn it the other way. We're like, this one is half of that one. I like doubling, not dividing. So if you had the measure of the angle out here, if you had the measure of the angle out here, which you do, because what's the angle if you go all the way around?
360.
360. So 360 minus 120 minus 100 gives you 140. So x is half of that, or this angle here is half of that, which is 70.
Okay.
So somehow you have to make the connection that this is an inscribed angle and this is the formula. You'll recall we did one earlier where we talked about a central angle.
Mm-hmm.
They're not the same. Obviously, inscribed would ends on the circle itself.
Okay.
All right, 46 here. Measure of angle x equals 126. That's 126. Find measure of angle z. Sometimes there is too many lines going. Okay, so let me draw this different. Here's x. So that's 126. So if we use the inscribed angle stuff from the previous problem, what is this that I'm drawing here? It's double that number there. So that's whatever it is. It's okay. Z. Oh, go ahead.
Is it 252?
Yeah, that's 252. Now,
Okay.
if we're trying to find z, so z is here's z. Okay, so if we knew this one, if we knew this right here, we could find z. Do you agree with that?
Yes.
Well, we don't have that, unfortunately, but we can get it. We can get it because over here, this is the same. These are the same. So we know the whole thing is 360. So 360 minus 252 gets you to 108. So this is 108 degrees out here. Therefore,
Okay.
z must be half of that, 54. I know this may not have been clear, but you have to draw it without certain lines and then with certain lines and then make the connection between the two drawings. You have to realize that you're taking part of one and putting it on the other. It's a very good question. It's very, very difficult to see, but it's only one, so I'm not sure if you get it or not. I mean, hope you don't, but we'll see. Okay. All right. Right. So 47 here. Okay, if MN and MO are tangents of this, find X. There's X. Okay. So this is, I think this is one of those walk around problems. If we draw, it gets like kind of like last problem. If you draw it without some of the stuff, which I know is a hard thing to do because you're used to seeing it. This is drawn really poorly, but these are both 2 because the tangents have to be the same. So then what is and if I redraw it over here, here's N. What is the length of this tangent down here? If the whole thing is 10, and I've already told you that part of it is 2, well, that's 8. X is this part up here. It's not clear, but it's only this part. So X must also be 8. 48. All right, find V to Y. So this is V to Y here, and I give you that. Okay. So what is the formula here? So the right. So the formula is, let me try to draw it over here off to the side. So you don't go through the center, that's why they're showing it off to the side here. I'm going to call this X, M, and M. So I believe it's X is equal to 1/2 M plus M. So it's kind of like the average of these numbers. So you have 64, and that's half of 48 plus the one we're trying to find, which we'll call big M in this problem. So you can solve this by, I would double both sides, like 128 equals 48 plus M, subtract 40, so M equals 80. A lot of these have just formulas that if you know the formula, you can find it, you can do the problem. 49 is I think the easier version of this question, which is I give you the two ones on the outside, and X is just the average of them. So X is equal to 1/2 of 122 plus 68. And I think that's the easier variation on the problem because the other one is the working backwards. So hopefully you got 95 for that if you worked it out. 50 is another formula. It's related to the one we just did, though, but it is slightly different. So this time you have the H is outside the circle. And what you have in this situation is you have what's called a big M and a little m, and you have X here. And X is equal to 1/2 big M minus little m. So again, like another formula, if you know the formula, you just put the numbers in and you go. Don't know how to help to suggest to do it other than to learn it. My understanding is you see similar problems to these, just different numbers, or they're the same problems altogether. So the instructors are really like, hey, please do the review. Okay, let's do 51. '51 is very much related. Here they're not giving you they're not giving you they're not giving you this little m, but x is still equal to 1/2 big M minus little m.
Mhm.
So 1/2 96 minus little m, which we don't know, equals 20. So you just substitute the numbers in and go on this.
Okay.
40 equals 96 minus m. M equals 96 minus 40, which equals 56. All right, so I'm going to just outline kind of what's remaining here. So 52 through 57, they're all kind of related. They're some circles and stuff like that, and some more circle stuff. Starting at 58 through 69, these are all area problems.
Mhm.
Most students find these aren't too difficult to do because they have formulas for them.
Yeah.
Okay, and then 70 through 76 are volume problems.
Mm-hmm.
And those are, again, if you have the formula, they're not too bad. Or no. Surface area. Sorry, surface area problems. So these are different. They're surface area problems. And then 77-ish through 84, these are volume problems. So a lot of students, they actually don't struggle too much with those, but you need your formulas for that to be able to find the values of them.
Yeah.
When is your final exam? When do we need to get that other session in?
It's tomorrow at 8:30
a.m.
Yes.
Okay, so I can do I know I can do an 8 p.m. I might be able to do a 7, but 8 p.m. is probably pretty solid if you want to do that tonight.
Okay.
Is that possible for you?
Yeah, I was just thinking, like, because this stuff is more recent, I think I just needed to brush up on some of the like older stuff from earlier in the semester.
Okay.
But like, I don't think we necessarily have to do another session for like area or something like that.
Up to you. Up to you. I'm going to leave these 2 times open for you.
Okay.
You've got so if you need them, they're available tonight for you.
Okay. Thank you.
All right. I'll send out the notes and the screen recording here in a little while. Thanks again for
Okay.
scheduling. See you next time.
Thank you so much. Bye.
Okay. Bye now.